superconductivity? Wowza! So super!
But wait, what exactly is superconductivity? Let's take a closer look, shall we? We have here a deck of elements. Pick an element, any element. This one? Great choice. We have here, of course, aluminium, which is a superconducting element.
Normally, when acting as a conductor, there are electrons passing through the aluminium, but they end up colliding with other atoms, causing unwanted energy loss. This is like walking through a crowd of people in a concert. It's really hard to do. But now, when we cool the aluminium, it falls below a critical temperature, and the electrons traveling through it form pairs, which are called Cooper pairs. Think of this like walking through rows of neatly organized people while holding hands with your friend. These pairs are held together by lattice vibrations, which create a coherent state where the electrons can move with less resistance than two separate electrons. And if they get directed off course, they'll quickly realign themselves with the other pairs. This allows for the current to continuously flow with very little resistance. This makes superconductive magnets very useful in certain applications, such as MRIs and maglevs. Using superconductors is not without its challenges though. Superconductors need to be kept at very low temperatures, which makes it quite costly and impractical to use outside certain cases. Temperatures are currently the big issue with superconductors, but scientists are trying to fix exactly that. In the 80s, they discovered a new material that had a critical temperature of around 90 Kelvin, which allowed it to be refrigerated with liquid nitrogen instead of liquid helium. Over time, we've managed to raise the critical temperatures of new superconductors to nearly room temperature, which opens up so many more possibilities for their use.
And that is superconductivity in a nutshell. It's so simple, you can learn it on a playground.